We build our greatest cities on what seems like solid, unmoving ground. But deep below our feet, the Earth is alive. It breathes, it shifts, it stores immense energy in grinding tectonic plates. For all our technology, we are often powerless guests on this moving stage, waiting for the ground to suddenly roar and shake. What if we could learn to feel the planet's subtle whispers, to sense a coming earthquake not seconds, but weeks before it strikes? Welcome to Boson Buzz. I'm Monty Molecule, and today we're going underground to listen to the planet's hidden rhythms. We're meeting the attentive guardians of our foundations, the Earth's pulse. Our story focuses on a bustling coastal metropolis, built right on top of a sleeping giant, a major fault line. The people here know the big one could come someday. The old warning system relies on seismometers, incredible devices that measure the ground's shaking the moment it starts. But that only gives a warning of seconds, maybe a minute, just enough to drop and cover. It's a last-second alarm, not a forecast. But now, scientists are installing a new kind of nervous system for the city and for the planet. Instead of waiting for the shake, they are learning to listen for the creep. They are deploying vast networks of incredibly sensitive new sensors, turning the ground itself into a giant information grid. Think of the Earth's crust not as solid rock, but as a giant, slightly spongy material under constant subtle stress. As tectonic plates slowly push against each other, the ground doesn't just sit still. It experiences tiny, silent deformations, a stretch of a millimeter here, a tilt of a fraction of a degree there. It's like bending a plastic ruler very, very slowly. You can't hear it bend, but you can see it. The new sensors are designed to see that bending. The first type of sensor is a supercharged GPS station. But these aren't for giving driving directions. They are bolted deep into bedrock and can detect movements as small as the width of a pencil lead over a mile's distance. They create a live map of how the landscape itself is warping under pressure. The second type listens for sounds we can't hear. Advanced acoustic sensors are placed in deep boreholes and along fiber optic cables buried in the ground. They listen for the faint, high-pitched cracking of microscopic grains of rock deep underground, a sign that stress is building and the rock is starting to microfracture. It's like hearing the creaks and groans of an old wooden ship before a major plank gives way. The third and most revolutionary sensor measures gravity itself, but with incredible precision. As the density of rock changes deep underground, from magma moving or water seeping through new cracks, the local gravitational pull changes by a tiny, tiny amount. New quantum gravity sensors can detect these infinitesimal changes, giving a kind of X-ray vision into the movement of mass deep below, something never before possible. All this data, the stretching, the tilting, the microscopic cracks, the gravity tweaks, flows into a central AI brain. This AI isn't looking for one big signal. It's looking for a pattern. It learns what the normal background hum of the region is. Then it watches for anomalies, a cluster of microcracks in a specific zone, combined with a strange tilt on a ridge and a subtle gravity shift 5 miles away. Together, these faint whispers might tell a story of pressure building towards a release, an earthquake. The AI's job is to connect these dots. Imagine you're trying to predict a thunderstorm. You don't wait for the lightning. You look for the signs, the air gets heavy and still, the clouds darken and tower upwards. You feel a sudden drop in pressure. Individually, these are just odd weather facts. Together, they tell a clear story of what's coming. The AI does this for the Earth. A tiny tilt near a fault might not mean much, but when that tilt is followed by a swarm of 1,000 microcracks a mile deeper, and the gravity sensor picks up a change in density in the same spot, the AI recognizes the pattern. It's seeing the Earth take a deep, silent breath before it might roar. This is not about predicting the exact second. It's about forecasting probability, like a weather forecast for geology. The system might raise an alert. The likelihood of a significant seismic event in the coastal metro region has increased to 35% over the next 2 weeks. This isn't a cause for panic, but for preparation. City managers could begin quietly checking emergency water supplies, engineers could inspect key bridges, and hospitals could ensure generators are ready. It transforms our relationship with the ground from reactive fear to proactive management. But the reach of this planetary pulse goes beyond earthquakes. The same network of sensors can detect other hidden movements. It can sense the slow, invisible inflation of a volcano as magma rises, giving much earlier warning of a potential eruption. It can track the silent, relentless flow of groundwater in giant aquifers, showing exactly where water is being depleted. It can even monitor the stability of the ground under massive infrastructure like dams or skyscrapers, warning of sinkholes or subsidence long before the surface shows any sign of trouble. Let's envision a future guarded by this pulse. Satellite maps show the sensor networks spread across the globe's fault lines and volcanoes, like a delicate web of feeling. In a monitoring center, a gentle alert glows on a map of the Pacific. The AI has detected a worrying pattern of strain along a deep-sea trench. Weeks later, a major earthquake occurs exactly there. But because it was far offshore and forecasted, coastal communities were prepared. Tsunami warnings were ultra-accurate. And while the wave arrived, the loss of life was minimal. The Earth roared, but we were listening, and we were ready. It's a profound shift, listening to the planet's quiet signs instead of waiting for its loudest shouts. The Earth's pulse turns the ground beneath us from a mystery into a conversation. It promises a future where we are no longer caught off guard but can stand ready, informed by the planet's own subtle language. If this idea of understanding our world's hidden rhythms intrigues you, please like and subscribe to Boson Buzz. Until next time, have a safe and curious week.